Hello, class. Today we are going to look at functions. And in the previous lesson, we looked at equations that had two variables. For example, y equals 3 times 2 to the x power. We were looking at their graphs. We were looking at whether they were discrete or continuous, whether they were curved or linear, whether they were increasing or decreasing. Today, we're going to look at the relationship between the variables and the notation for a function. So first, are we related? Examine the table of inputs x and outputs y for the values that are below. Is there a relationship between the input and the output values? So the first thing I'm going to do is I'm going to look at the outputs and see if there's a pattern. -4 to -1, that would be +3, -1 to 2, also +3, 2 to 5. So we're noticing a consistent pattern of adding 3. So repeated addition is represented by multiplication. That repeated addition tells me that this function is going to have something to do with 3x. Now, I notice if I do 3 times 1, I get 3 and not 2. If I do 3 times 2, I get 6 and not 5. So the expected answer was 3, but the table only has 2. 2 times 3, the expected answer would be 6, but there's only a 5. So each time, 3 times 3 is 9, but I've only got 8. You always need one less than what you were expecting it to be. And that's how you would go about finding your equation. Now, I could put y equals. In order to get the output of y, I would have to do 3 times the input value and then subtract 1. Well, when we look at a function machine, it says a function works like a machine as shown in the diagram below. A function is given a name that can be a letter, such as f or g. The notation f of x, where you see the x here is in parentheses, represents the output when x is processed by the machine. So f of x is what we're using in place of the output y. So instead of the equation being y equals 3x minus 1, we're going to represent it as a function of x equals 3x minus 1. So if we plug in x as the input, that's why there's an x here in parentheses. The result is a function of x. So if we look down here, numbers are put into the function machine. In this case, f of x equals 3x minus 1, one at a time. And then the function performs the operations on each input to determine each output. For example, when x equals 3 is put into the function, f of x equals 3x minus 1, the function triples the input and then subtracts 1 to get the output. So we're doing f of 3, right? Because we're putting 3 in, and that would be 3 times 3 minus 1. We'd have 9 minus 1, which is 8. And down here you can see when f of 3, 3 being the input, so a function of 3, we get 8 for the output. Calculate the output for f of x equals 3x minus 1 when the input is 14. What we're asking you to do is find the function when x is 14, or f of 14. So f of 14 equals 3 times 14 minus 1. So the function of 14 is 42 minus 1. So when 14 was my input, 41 is my output. Find the value of f of negative 10. So same idea. If it's f of negative 10, we're going to do 3 times negative 10 and then take away 1. And 3 times negative 10 would be negative 30 take away 1. So the function, when negative 10 is the input, negative 31 is the output. If the output of this function is 24, what is the input? So if the value of the function of x is 24, not the input, if the output is 24. So we're saying if this is an f of x equals 3x minus 1 and f of x is worth 24. Previously would have said if y is 24. And then we would see this as a two-step equation. We would add 1 to both sides. We would have 25 equals 3x. We would divide both sides by 3. Now, you could come out with a mixed number, but there's absolutely nothing wrong with your final answer being an improper fraction as long as it's in lowest terms, and 3 and 25 don't have anything in common. Determine the relationship. Oh, yep. So we're done on that one. It says, is more than one possible input? Is there more than one possible input? No, this one only has one possible input. There was nothing to do with any sort of squaring or square rooting, which might have resulted in more than one. We never got x equals x. So this one only has one possible output. Oh, I'm sorry. Nope, only one possible input. The output was 24. The only possible input is 25/3. All right, determine the relationship between x and f of x in the table below, and then write the equation. So first of all, we've got a 1-to-1 here. Okay, so that's sort of a hint. We've got a 49 relationship with 7. We've got a 25 relationship with 5. Those are the ones that we sort of have to base our hypothesis on, because those are the ones where we have both the x and the y value, both the input and the output. And it appears to me that this is either a squaring or square rooting function, because I know that 7 squared is 49, 49 square rooted is 7. I know 5 squared is 25, 25 square rooted is 5. But I've got to say, if x is the input, if I plug in 49, how do I get an output? How do I get an answer of 7? If I plug in 25, how do I get an output of 5? So this is going from a larger number to a smaller number, and it's got to be square root in that case. So the f of x is equal to the square root of x. So the square root of 9 would be 3. The square root of 100 would be 10. The square root of 4 would be 2. The square root of what number gives us 4 is the output. So this one is bigger, it's 16. Square root of 0 is 0. And the square root of 20, we would have to approximate. It's approximately 4.5. You could use a calculator for that, or you could estimate that. And we did estimating radicals last year. You'd be estimating the square root of 20. And you could say, well, it's between the square root of 16 and the square root of 25. Hopefully this sounds familiar, meaning that the answer is somewhere between 4 and 5. And it's pretty closely split. You might have even gone with approximately 4.4, and I went with approximately 4.5. My guess is that it rounds up to 4.5 on the calculator. All right, so here we have a number of function machines. Determine the corresponding outputs or inputs for the following functions. If there is no possible output for the given input, explain why not. So the first one, the input is -3. So we're going to say that in order to get f of x, we've got to do -2 times -3 and add 4. So -2 times -3 is 6 plus 4, meaning that the output is 10. So right here we can say output is 10. F of x equals 10. If x is 2 on our function, 3 times 7 to the x power. So 3 times 7 to the second power. Exponent comes before multiplication, so 3 times 49, or 147. So our output, f of x, would be worth 147. On this one, we're looking for the input. What is the input? And it's a function x being cubed, and f of x is worth 125. So we can say 125, the value of f of x, has to equal x cubed. So we need to remember from last year that the inverse of cubing is cube rooting. So we would want to cube root the left side, and we want to cube root the right side, and we would get 5 equals x, or up here, x equals 5 for our input. You can't forget to do this, though, ladies and gentlemen. Everything has to look algebraic, so whatever you do to one side, you have to do to the other side if you are solving an equation that still has the equal sign. The first two, we were simplifying the right side of the equation, which is like simplifying an expression. But this one, we had numbers and we had operations on both sides, so we had to do something to both sides. All right, in here we have the input is -2, so f of x equals the square root of -2, and then there's a +1 on the outside. And this one, you're going to have to say no output possible. We had this come up on one of our very first video check-ins. You cannot square root a negative number. So no output possible. And the reason for that is cannot square root a negative number. X equals 2. Now this one is a little bit small. You're going to want to make sure that you write it out carefully. X plus 3 is going to become 2 plus 3. And 2 times the input 2 minus 5. Now, when you have an expression with the fraction bar, you can either work horizontally and use the equal sign, or you can work vertically with no equal sign. This one, I don't have a whole lot of room, so I'm going to go horizontal for that first step. And then it's going to be 5 over -1, which is -5. So our output is -5. Notice I did everything in the numerator separate from everything in the denominator. And at the very end, the last step was dividing using the fraction bar, 5 divided by -1. All right, this one we're looking for an input. So we're going to have things on both sides. The value of f of x, the output is 99. So 99 equals x squared minus 1. It's an equation. I have to do things to both sides. So I'm going to add one on the right, add one on the left, get 100 equals x squared. And I'm going to square root both the left and the right. Now, don't forget, when you square root a number, there are two possible answers, plus or minus 10. It could be 10 times 10 equals 100, or it could be negative 10 times negative 10 equals 100. So this one has two possible inputs, negative 10 or positive 10. Two possible inputs. And this is really, a review. Yes, we've done this before, but a lot of times we forget from the previous school year. All right, so this one we are also looking for the input. What is the value of x if f of x is worth negative 3? Well, that's interesting. You're asking me to get a negative output from an absolute value. And we know that absolute value always comes out positive. So this is one where we would say no input possible. And that's because you cannot get a negative answer. Messed up there, but that's okay. Can I get a negative answer to absolute value? Absolute value, always positive. All right, next one. If the input is 4, so 3 to the 4th power. So this one is going to be 1/2 times 3 to the x, or 3 to the 4th power. So 1/2. Now 3 to the 4th power being 3 times 3 times 3 times 3, which is 81. And half of 81, I can either do 81 halves, or I can do 40.5, or 40.5, said the right thing, or 40.5 is a mixed number. Any of those acceptable. This one had a fraction in it, so the best answer would be the 81 halves, because it is the simplest of the three and still maintains the fraction that was in the original question. Input a negative 4. All right, so this is absolute value, but notice we are inputting a negative, which we can do. So f of x equals the absolute value of negative 4 minus 2. The absolute value of negative 4, distance from 0, is 4 minus 2. So the output, 4 minus 2, the output is 2. So output of 2, one possible answer there. So absolutely, no pun intended, you can take the absolute value of a negative number. You just cannot get